Hello, Mrs. Hoekstra here. Module 3, Lesson 7. We are on page 51, and you'll notice the essential question's already up, but the lesson is about understanding equations. And the essential question is, how do you know a number is a solution to an equation? You'll notice that there's a whole bunch of vocabulary on here. I've already given you guys those vocab words, but even if you need to talk about them, we'll do that in class. So I'm actually going to change over and jump over to page 52. All right, your brother's going to college and you no longer have to share a bedroom. So you decided to redecorate the wall by hanging 2 posters on the wall. The wall is 14 feet wide and each poster is 4 feet wide. You want to place the posters on the wall so that they are the same distance from the edge of each poster to the nearest edge of the wall, and it's the same distance between the posters. All right, so if you take a look, there's our diagram. And you know, this is pretty real life, guys, where you're like, all right, how far apart do I have to measure these? Right, so I have 14 feet there, and I know I'm already using up the size of the posters, right? So I could do the 14 and subtract the 1 poster on the left and the other poster on the right. So technically, the amount of space I have left over is what, 14 minus 8, so 6 feet. I've got 6 feet to split up, and I've got to split that amongst the 3 spots, right? I've got 3 spots, 6 feet divided by 3, so we're going to guess that they're all going to be 2 feet apart. And let's see if that makes sense. If I put 2 here, and another 2 here, and another 2 there, if I add that all up, does it actually get me to the 14? So 2 plus 4 is 6, plus another 2 is 8, plus another 4 is 12, plus another 2 is 14. Yeah, it worked. All right, good. That makes me feel better. So I know that the answer is going to end up being that way. Well, let's change up the problem a minute. Your parents are redecorating the dining room and want to place 2 rectangular wall sconce lights, right? They're special lights that are 25 inches wide along a 10.5 foot or 10 2/3 foot, excuse me, wall, so that the distance between the lights and the distances from each light to the nearest edge of the wall are all the same. Okay? So here's the drawing of how this is going to look again. Your parents are like, hey, you know, you did a great job with figuring out the one for your room. Can you help us with this one? Ooh. So a couple of things we have to notice in the problem. First of all, the wall is in feet. The sconces, the lights, are in inches. So we either need to change everything into feet or everything into inches. Okay, I think what I'm going to do is I'm going to change everything into feet. All right, I'm going to change everything into feet. So that being said, I'm going to change 25 inches, right? 25 inches, and there is 12 inches in a foot. So if I do 25 divided by 12, I'm going to get 2 1/12 feet. Okay, that's what 25 inches will be. All right, so that, we've got that. So this is really 2 1/12. This is 2 1/12. And then I've got those 3 spots that I don't know again. Well, could I do it the same way as I did a while ago? Sure. 10 2/3, right? Minus my 2 1/12, minus the other 2 1/12, because I've got 2 of those. I could write this a little differently. I could also write this as 10 2/3 minus 2 of these 2 1/12. That might help me, I don't know. Okay, and then I still have that spot that I don't know. I have these unknown places, right? Plus those. So technically I got to deal with that as well. So the arithmetic gets a little heavy, gets a little confusing. So that's why I'm going to use some algebra here. So what I'm going to do is I'm going to take my 10 2/3, because that's how long the whole wall is, and that's going to equal the size of the lights, which we know is 2 of them at 2 1/12, plus I have 3 unknowns, and my unknowns, I'm going to call that X. I don't know it. I have 3 of them. Now I could pick any letter. I could pick an emoji. All right, I could do something to represent the unknowns. If you wanted to even put a question mark there, make it 3 question mark, that is perfectly fine as well. All right, well, a minute ago, I was doing this arithmetic here. I was doing this So I probably could do that still some more. So really I have 10 2/3 minus that 2 2/12, which by the way is 10 2/3 minus, this becomes 4 1/6, okay, when I do the math. And by the way, this is still now all going to be equal to that 3x, those three things I don't know, that three missing parts. Whatever that subtraction is, if I divide that by 3, I'll get my answer. Okay, so this gets pretty messy pretty quickly, and you know what, I'm not going to deal with it, but this is kind of what we're talking about, like what's going to make that work, right? What numbers are going to make that work? And that's what we're talking about in the lesson today. And you're like, but I want to know the answer. We're not going to get the answer right now. Okay, by the way, remember I did mention that we could have changed it into where we were working with inches instead of feet. Well, that's what I want to do over here. So instead, let's take our 10 2/3 feet and let's change it over to inches. So 10 2/3, well, we all know that there are 12 inches in a foot. So I'm going to take 12 times 10 plus 2/3 times 12 to figure out how much that is. So this is 120 and that equals 8. So 128 inches. Would it be easier than doing that other problem? I think it will be. All right, I have the 2 wall sconces, right? And we said those were 25 inches each, plus the 3 unknowns. I'm going to make it 3x, and that has to equal the entire length of the wall, 128. I don't know about you guys, but I think that way would be a lot easier to work with. Oh, they said use y. I'm sorry. Let's use y. Y for the length in inches. Okay? I think that would be a lot easier to work with than the problem across the page, right? That one there, ugh. Even though I like my fractions, I don't want to work with them if I can avoid it. And look at that. I totally avoided it. Not going to worry about what the answer is to this right now. We can solve it. We will get there eventually. Right now, we're just going to kind of leave it out there. But it does ask, well, which one of these 3 answers here make this true? Which of these make it true? So what we're going to do is plug in each number for y. So where the y is, we're going to put it in. Well, we know that 2 times 25 is really just 50, right? 50 plus 3y equals 128. It's kind of a little more simplified. So I'm going to plug those numbers in now. So 50 plus 3, now this means we're going to multiply, times 24. Okay? And we want to know if that equals 128. So I have 50 plus 3 times 24 is 72. Does that equal 128? 50 plus 172 is 122. That does not equal 128. Okay, so 24 is not a solution. 24 is not a solution. Didn't make it true on both sides. Well, let's do the same thing with 25. So 50 plus 3 times 25. Does that equal 128? So we have what? 50 plus 75. 50 plus 75 is 125. That does not equal 128. So 25 is not a solution. Now don't assume that 26 is just because the other two were not. 26 could just as well not be. So we're going to have to plug it in as well. So again, 50 plus 3 times 26, does that equal 128? So in other words, 50 plus and 3 times 26 is, where's my answer? There it is, 78. 50 plus 178, or excuse me, plus 78 is 128. So 26 is a solution. So you can always just plug a number into the equation, see if both sides equal each other, right? And there you go. Not too bad. Okay, let's try to take a look at what happens on the top of page 54. Top of page 54, ages of 3 sisters are consecutive integers. Okay, vocab. Consecutive. 3, 4, 5, they're consecutive. A, B, C, they're consecutive. They're all right in a row. Integers tells me that they're whole numbers, right? And their ages, when combined, the sum, addition of their ages is, there's your equals, 45. So let's go with X being the little sister. Okay? The next sister older is 1 year older than her. So it's X plus 1. That's the middle sister. And then the oldest sister is a year older than that one, or 2 years older than the little sister. Okay? That's consecutive numbers, right? It could be 6, 7, 8. It could be 25, 26, 27. We don't know. Okay? But we do know that if we take their ages, right? Here's the little sister, and we take the middle sister, and then we take the oldest sister, and we add them all up, it equals 45. Okay? That's what they're asking about. Is there a way to find this? Oh, I did this for part B. I like to just jump into the algebra. All right, so let's do the tape diagram. We'll put that one down here. And let's see if we can figure this out with the tape diagram. So let's call the first sister, sister X. The next sister is X plus 1. And then the oldest sister we said was X plus 1 plus 1. And we know that all of this equals 45, right? Well, I've got these 3 here. Couldn't I take that off of this, remove those, right? Take them out. But if I'm going to remove 3 from one side, I got to remove 3 from the other side. Okay, so this now becomes what? 42. So I have 3 things that I don't know. I've got 3 of these rectangles. Oop. 3 of these rectangles, and it's going to equal 42. I'm going to erase that 3. Okay, I've got 3 of these rectangles, and it has to equal 42. So in other words, if I take 42 and divide by 3, I should find out how old X is, whatever X is. In this case, X is 14. So the littlest sister is 14. The middle sister is 1 year older, and the oldest sister is a year older than that. So in other words, 14, 15, and 16 years old. Okay? Determine if the answer in part A and B, right, if they are actual solutions. So we had 3, what did we have up there? We had, oops, we had X plus 1 plus X plus 2. We said that that all equaled 45. And we said that X was 14. Well, what's 14 plus 1? Sure enough, that's 15. That's that middle sister. And we said 14 plus 2 is 16. Sure enough, that's the oldest sister. And if I add that up, does it actually equal 45? This does equal 45. 45 equals 45. It is a solution. Okay, we were right. We got both sides to equal each other, so we're good to go. All right, I would like you guys to see if you could figure out page 55. Play around with them. It's okay. This is just practice. I want you guys to try A, B, C, and D on your own. Hit pause, and then check your answers with me in a minute. All right, hit pause. Okay, so the membership fee is added to all of the answers. And so you have $19.99 membership fee plus 99 cents for every song. She's buying 2 songs, so it's going to cost her $21.97. Sophia purchases N number of songs for any number you would just change it to $19.99 plus the 99 cents for any number of songs, and then you can calculate her price for any of them. Sophia's friend saved $118, but isn't sure how many songs though she can get. So if they write this particular formula right here, they can use it to solve it. And then they just start kind of guessing and checking, plugging numbers in. So they kind of started pretty high. I mean, it's going to be a lot because you're paying only $1 a song. So if they plugged in 101, it's over, right? It's $19.98. When you put in 100, it was $18.99. We're getting close. So if they buy 99 songs, her friend will be able to spend all $118. All right, that is it for today. Yeah, that was a nice short one, wasn't it? I will see you all in class later. Bye. Bye.